So in this video we will gonna solve this merge sorted array problem, the Leetcode problem. In order to solve this Leetcode problem, you have to have a basic knowledge of arrays and how the array data structure works. And if you're quite familiar with that, then you are easy to go in this problem. So it's an easy problem. You are giving the two integer arrays nums1 and nums2 sorted in non-decreasing order. Like it is sorted in ascending order, right? And the two integers m and n are representing the number of elements in nums1 and nums2 respectively. So what does it mean? It means like that there are two lists like this. This is the first array and this is the second array nums2. So the number of elements in the nums1 are 3, so it's defined by 3, and the number of elements in the nums2 are also 3, so it is defined by n variable. So what do we have to do? We have to just merge these two arrays into a single array, and we have to just make sure that the array should be sorted in ascending order, right? So it is written here that the final sorted array should not be returned by the function, but instead it should be stored inside the array nums1. So we have to update the nums1 array, took this array, the nums2 array, and take out these elements and just put it in the nums1 array in such a way that it should be sorted in the ascending order. So how we're going to demonstrate this here. Let's say in the first array we have like this. This is the nums1, I must say. This is the nums1, right? And we have a nums2. Here I will write nums2, and the nums2 contains 2, 5 and 6. So these are the two arrays that we have in this problem, like this. So these two arrays, what we have to do here is that we have the first, here is the length of this, the number of elements are 3, and here also the number of elements are 3. Now why does these two things are available to you? It's on purpose. First, what we have to do, we have to just check this one. So if we have to update the nums1 variable, the nums1 list here, so what do we have to do here is that we have to just check the numbers. This number, we have to just check it from the last index. We have to check from this last index. Here we have to check it from the last element in the list. So in the last element, this is the 3, and here the last element is 6, right? So these 0 0, you might be thinking why these 0 0 are not a part of the list. So I say that these zeros are just defining only the spaces of the array, right? So this is the spaces of the array and it is not a part of the elements, right? So if when we are talking about the elements, then it is the numbers greater than 0, not the 0, right? So the 0 is like an empty space, or you can say an empty indexes. So here you can see this is the 3, the last index, and here is the 6. So we have to just compare it. So if the 3 is greater than, no, it is not greater than 6. So what do we have to do here? First we have to just set some pointers here. Let's say I just pointed out I at this index right here, and I just pointed out just j here at this index, right? What do I have to do here? Additionally, I have to just make it sure that I have to implement this like there here. Let's say I, how does the I works? I will work in a way like m minus 1. So it is here at this index, right? M is 3 and it is at index 2, 0, 1, 2. So it is at index 2. I is at index 2. And how we're gonna see j? J is at the index 2 also. J is equals to n minus 1, right? So this is the whole thing. So j is here, I is here, and we have to add one more pointer, which is k. K is equals to m plus n minus 1. M plus n minus 1. So here it is the m plus n minus 1. What do we have to do? We have just these 3 pointers. I have to just here, yeah. So m plus n is equals to 6. This is 3 plus 3 is equals to 6. The final, you can say the value will become here. I must say the final value is the 6 minus 1, that is 5. So the k should be pointing here at the 5th index. You can see here, this is here. This is 0, this is 1, 2, 3, 4, 5. So this is the 5th index. So k is pointing here and the j is pointing here. So first what we have to do, we have to compare the I with j. So when I just compare with I is 3, j is 6. So we can clearly see that j is greater than I. So what we're going to do, we're going to replace, we're going to put this j6 into this k position. So I am just updating this nums1 in here in the last, I'm just updating this. So this is the nums1 updated. Nums1 is equals to 1, 2, 3 and comma 0 and 6. So this is so far the nums1 list has been updated here. So this is the nums1 till now, and now the j has been updated here, and you have to just see. Okay, so the j has been updated here, and what we have to do, we have to just update this j. We have to just update this k and j. So the k will be updated like this, and the j will also be updated. So the j will be updated. So now the k will be pointing here, and now the j is pointing at this index. Now again, it will see if I is greater than j. No, j is greater than I, so we will just put this 5 on this k index. So if I just come here, and you can see, so this will become 5 here, right? So it is 5. Now the nums1 array, the final nums1 array will look like this. Now again, the j and k will be updated. Now the j and k will be updated here. Now the k is pointing here at this index k, and now the j is pointing to 2. And at this thing, we have to just compare it with this. Now you can see I is greater than 2. Now if I is greater than 2, then we have to just replace the I. We have to put like this is the greater than this one. So we have to first shift this 3, this index to this one. So this will become empty, and we have to just replace this one to the previous index like this. So I'm just demonstrating like this. So the 3 will be, this will become 0, and this will become 3. So I've just shifted the 3 into the next index, and in the end this 2 will be placed here. This 2 will be placed here. So you can see this will become our final list, the required list, and this is the output. So this is how this algorithm is working. The first thing first, I have to just initialize some of the variables I, j, k, and I is m-1, j is n-1, and k is m plus n-1. So these are the three things: I, j, k, m-1, n-1, and m plus n-1. These are the three things that you have to do. And the second thing is that we have to initialize, and we have to just check while. I'm just writing the while I is greater than equals to 0 and j is greater than equals to 0. So what do we have to do? We have to just check this condition. If I is greater than, you can say, sorry, if nums1 I is greater than nums2 j, or you can say the first condition, yeah, nums1 I is greater than the nums2 j. So what do we have to do? We have to just replace it. What did we do here is that if the nums1 I is greater than j, so we just place this nums1 I to the kth index, right? We have just put this at the kth index. So here I will just nums1 k is equals to nums1 I here. This will gonna do, and at this point I will just gonna decrement this I by 1. And else if the I is less than j, if I is less than j, so what did we do here? Then I was less than j, then we were just replacing the kth element with the jth element like that. So I will just implement this, that nums1 k will be replaced with nums2 j, and at this point the j will be decremented, and also at every point we will gonna do like k will be decremented at every single point. So the k is decrementing. So this is the thing. And the last thing I want to tell you here is that while if you just see like that, if the list has been ended, if the list is completed, then what do we have to do? We have to just put the remaining elements from the nums2 to the kth element of the nums1. So what we have to do is the nums1 k will be replaced with nums2 j, the remaining thing, and at this point we'll just decrement this, and here we go. This would be the final look of this whole code. We are not returning anything because we don't want to return anything in this code, and just let's just run this code and let's see if the test is correct. I must say, yeah, so it is accepted. So the 3 test case runs are here, and you can see all of our connected. So what are the time and space complexity? So the required time complexity was O(m) plus n, and exactly what we did here. So the exact time and space complexity here, I must say time complexity is big O of m plus n. So it will totally depend on the length of the nums1 and nums2. It totally depends on that. And the space complexity is big O of 1. Why? Because we are just updating the final list, the nums1 as the final list. We are not using any kind of new list or any new data structure here. So we are just using the same list and updating the same list. So the space complexity will be constant. So this is how you can solve this Leetcode problem. This is a merge sorted array. I hope you understand this. If you have any question, you can just ask me in the comment section. Thank you so much.